Hello, in this session I want to go over a topic called predictive modeling, and it's an area within data mining. Alright, so the objective of this presentation is to kind of go over the basic definition of data mining, and also describe two major types of data mining analysis techniques, and we'll also look at some techniques that can be used for what are called supervised and unsupervised learning situations, or supervised and unsupervised analysis situations. Now, the data mining is an iterative process of creating predictive and descriptive models. Okay, and you do that by uncovering trends that were not known before, and also discover patterns in the data. And usually there's large amounts of data. And the whole idea is you want to make better decisions in the business, and so that's why you use data mining techniques. And it's a subset of business analytics. Business analytics would include things like reporting, dashboards, and so on. And data mining is more about analyzing existing data. The key words here is iterative. Okay, iterative, it means you're going to do this over and over again, and with data mining projects, the analysis may go for many iterations, and you may not stop with the first set of analysis. You might want to do further analysis into data, maybe collect more data, and so on. So it's an iterative process. And also another thing is you're going to be creating models, and which means you're going to be associating variables and trying to find out if there are relationship between variables, and sometimes you find there is no relationship between some variables you selected, so you might go ahead and drop those variables and pick some other variables. So you try creating different models, and whichever model that best fits the data, you will go with that. And you will find trends that were not common sense, and sometimes they are counterintuitive, but sometimes the data might tell you underlying trends, and these techniques can help you discover them. The whole objective is to support decision making. Organizations want to know how a particular product promotion strategy is working, or they want to be able to go after certain type of customers, or they want to be able to respond to customer requests in a quicker fashion. And so there are a lot of different decisions that organizations need to make, and data mining techniques help make those decisions. Now, there is no shortage of data. Data comes from things like it's a lot of health related data coming from hospital patient registries, and there is point of sale data being generated, millions and millions of them every hour from these point of sale systems, and stock trades that are happening every second or every fractions of seconds, and so on. There's a lot of online transaction systems, telephone calls being made and received, and all this data gets stored to servers and can be retrieved and analyzed and catalog for online stores, bank transactions that customers make, and there are satellites sending out remote sensing images. There's tax data and airline reservations, and lots of different ways that data keeps coming in. So there is no shortage of data. Now, who does what with the data depends on what the purpose is. And you could say there are two different areas where data get used. One is in academic setting, other is in business setting. Academic setting, I would say, is the experimental, whereas business setting is more opportunistic. And the academic setting, when you do an experiment, set up an experiment, collect data, the purpose is research, whereas in business, when you collect data and want to analyze it, you want to make use of the results and bring it to operational tactics for organizations. And the why organizations, or why academic organizations do research, scientific reasons. They want to advance theories or develop new theories, and or explain existing theories, and advancement of knowledge is the purpose with academic experimental folks, whereas business use of data mining is all about commercial. They want to be able to save money, make higher profit, and retain more customers, and so on. And the generation of data in academic setting or experimental setting is actively controlled. They make sure they know how to measure the data, and they set up situations where data get generated and they use the data. Whereas in the business or opportunistic world, data keeps coming and you're observing it passively. So you use the existing data that to make analysis. And also the size of data sets handled by academics versus business would be very different. And the data from the academic environment, experimental, will be very clean. They would make sure that the data is accurately measuring what they want to measure, whereas data that comes in the business world may not always be accurate. But since they have huge amounts of data, sometimes there's a trade-off between not so accurate data versus large amounts of data. The data that business academics use is usually it doesn't change over time, and once they collected it, may keep it for a long time, whereas businesses keep collecting new sets of data and the new analysis need to be done every few weeks and so on. All right, and data mining as an area of interest has you can trace its foundations to various disciplines, and statistics is one, and where data using statistics is the science of data, and it's been around for many centuries, and a lot of techniques have been developed over 2-3 centuries ago, and so use of statistics is important in data mining. Neurocomputing is being able to model the way natural systems like neuron systems work, model them in computing environment and can abstract it, and so there are techniques called neurocomputing techniques, and there is an overlap between neurocomputing. There is not much overlap between neurocomputing and statistics, but there is this area called pattern recognition, which uses both statistical techniques and neurocomputing techniques for doing things. And also artificial intelligence is another area within the computer science world, and lots of advances have happened. AI has been around for many years, many decades, and it has a lot of contributions have made it to commercial products, and AI is a important area from which data mining techniques, some data mining techniques are derived, especially to do with the neurocomputing. And there's also something called machine learning, where we are able to detect patterns and make the machine learn from the patterns, and that's something we will see how it gets applied. And there's also the areas of statistics, pattern recognition, and machine learning. They all kind of lead to what's called knowledge-driven development. So we can create knowledge bases from existing data sets and using these techniques. And of course, when you talk about data, you need to have means of managing huge amounts of data, and there are techniques for relational databases, simple text files, CSV files, Excel files. There are also new technologies called Hadoop, which allows you to store huge amounts of data for analysis. Now, so data mining is a kind of conglomeration of all these different concepts, and so it's good to know that these are the basis for data mining. All right, now there are two types of data mining analysis that this course will focus on. One is called unsupervised learning, and in unsupervised learning there is no reference data to compare with. So you basically have a whole bunch of data, and you want to try and discover clusters or patterns in the data. And one technique is cluster analysis, where you try to classify existing data into different clusters. Another technique is called association rules, where we try to find out what goes with what. For example, in a grocery store basket, there may be you may be buying like milk, bread, and peanut butter, and or you might be buying salsa and chips. So there are combinations of products that people tend to buy, and they tend to be in the same basket, and so to discover which products are bought together, there is a technique called association rules, and that lets you discover what products are most commonly bought together and so on. And there are also other techniques that you can use. So these are simply, use the existing data to discover new patterns. That's called unsupervised learning. Now there's also the other technique called supervised learning. In supervised learning, you already have kind of a reference data to compare with, and say for example, if you're trying to come up with a model to predict student GPA, you could be looking at things like how many classes the student took and what the student's ACT score was, or you could look at how attentive the student was, and so on. So that if you have quantitative data on this, and if you have data on student GPA, and then that will be a way of coming up with a model that predicts GPA, but you already have existing GPA data to compare with. And the idea is to do prediction, and linear regression is a technique that we have touched upon earlier, which lets you set up a linear function as a model to represent the relationship between independent and dependent variables. There's also another technique called logistic regression, and we'll see what that is. There's also a technique called decision trees, and we'll also see description of decision trees and see how it's done in SAS. And there are other techniques for prediction. Just to give you an idea what cluster analysis is, cluster analysis basically is a technique for grouping records based on common characteristics. Say for example, you want to classify students at a university based on the types of electives they choose. So if somebody is choosing lots of arts electives, then you could say the student has more tendency towards art. If a student is taking a lot of agriculture related electives, then the student has interest in farming and so on. So that may be based on existing data. You can try and classify students, create clusters, or create clusters of customers by demographics. So we could be looking at customers' age, gender, race, zip code they live in, their income level, and number of family size, number of kids they have. So these are demographics related data, and we could use them to classify customers as a single parent customer, or a joint family customer, or unmarried bachelor customer, and so on. So there are various ways of classifying data based on demographics. Banks may want to classify create clusters of customers by amount of transaction they make, number of transactions they make, how recent their transaction was, and the amounts of transaction they make. These all can be used to classify clients. So these are all about what we call cluster analysis. Okay. So clustering, the thing is, these clusters that we're trying to do is not something that is known in advance. So you basically have your input variables, but you don't know what cluster a particular case may belong to. So cluster analysis technique will help you find that, and will help you find and figure out that you're going to have 3 clusters in a data set, and so case number 1 and 4 they are very similar together, so they belong to cluster 1. Case number 3 and 5 are very similar together, so they belong to cluster 2, and so on. Now on the other hand, in supervised learning, where you're trying to predict, based on the inputs, you can come up with some kind of a probability of something belonging to a certain class. Okay, so that means based on student GPA and number of classes the student take, we can come up with a probability that the student will have this level GPA. All right, so we'll see that. Now a lot of times when you talk about predictive modeling, you have your input data, and also one of the input variables is called the target variable. The target variable is like the dependent variable that you want to try and predict based on. All right. So there are different types of targets you can think of. One is a binary target, yes/no type target, and in that case you want to, you can use a technique called logistic regression. And if you have a target that is multiple classes, such as let's say you're trying to classify customers as low loyalty, medium loyalty, and high loyalty. Then there's a multi-class problem, and you can use logistic regression for doing that. Sometimes your target variable is continuous, then standard regression technique will be acceptable. Sometimes you have target variables that are essentially giving you information on how much time before which somebody may react to. So that techniques called survival analysis. We will not be going over survival analysis, but it's an also topic that is useful. And now let's take some examples of discrete targets. If it's a healthcare related discrete target, whether it's after diagnosis, you could say the favorable outcome or unfavorable outcome. And or with credit scoring, you could say whether the customer will default on a loan or will not default on a loan. These are binary outputs. In marketing, you could try and target that this customer will purchase product A, or purchase product B, or purchase product C. So there could be multi-level kind of discrete values. On the other hand, continuous targets. Variables could be in healthcare. You could say how long a customer may stay in a hospital. That may be of interest for a data analyst, or how much cost this customer is going to incur. So these are continuous variables. And in finance, you could say amount of money you could a bank should keep in an ATM. And so that could be a target variable. Or if you're talking about commerce, you could say how long a vendor may expect to pass between sale of an item and return of that item. And so that's those are things. Now let's take up some examples of how prediction modeling can be applied in various areas in business. And so if you're talking about target marketing, let's say we have data on customers or prospects and households and so on, and we got data on their demographics, the geographics data, psychometrics, and RFM variables. And geographics refer to the geographic location vendors or the customers live in. Demographics refer to the demo, such as whether the customer's age or customer's race, gender, income level, education level. These are all things relating to demographics. Psychometrics relate to the customer's attitude towards life, customer's aptitude on a particular topic, customers' opinions, customers' lifestyle, customers' preferences. They may be relating to psychometrics. RFM is relating to business transactions, how recent a customer transacted with you, how frequently, and how much money, and so on. So these are inputs. The response, the target variable or the dependent variable would be maybe to how a customer may respond to a test solicitation. So you wanted to ask the customer to try a new product, and whether he will respond positively or negatively. That may be the target variable, and you want to try and maybe predict the target variable, whether he'll respond or not based on that. And so how you do that, if you have data on past responses, then you could use the input variables to predict the output variable, and then possibly use those combinations of input variables for future campaigns. Another example would be customers leaving, customers joining a business and then leaving business, so attrition and defection rates. And based on the customer's payment history and how much product and service the customer used, customer demographics, we want to try and predict whether the customer will stay or leave. So target maybe churn rate, whether how long the customer will be with you and go on to different competition. After some time, there is churn rate, and whether the customer will be switched to a different brand or may cancel subscription or may just drop out. So these are things you want to be able to predict. And so what you do is you try and do loyalty promotion and see how that will affect your target rates. Fraud detection is another area that data mining techniques have been used for a long time, and based on the trend, past transactions, you can see whether the customer is likely to make a particular purchase or not. And so the target could be maybe a fraudulent transaction. Say for example, if you use a certain credit card only for buying gas, and suddenly if that credit card is being used for buying a huge amount, let's say a big airline ticket purchase, then that might raise a flag on the cardholders system, and the cardholders, the bank's database system, and at that point the bank might not accept the transaction, may require that the checkout person verify the customer's ID before processing, so possibly preventing a fraud. And so sometimes you may want to impede suspicious cases, or maybe try and investigate suspicious cases. So these are also technique for data mining. And credit scoring is another way to classify customers based on past applicants. You can try and find out credit bureau reports, and from that you can try and figure out default, whether somebody will default or not, and whether somebody will become delinquent on payments and so on. So these are things you want to try and target, and so this data could be either used for accept or not accept or reject application for credit. So this is another example of how businesses may use data mining techniques. Thanks.